We live in an amazing age of machine intelligence. Traditionally, computers have specialized in following given instructions in the form of a computer program to perform calculations, compare values, operate hardware, and various other tasks. These are very coarse, high-level actions that direct a computer to do something in a step-by-step fashion. Yet, this approach doesn't work well for perceptual tasks that a human being might be able to do, but can't quite break down into steps. In fact, a human being may not even fully understand how they do it themselves. For example, human beings are able to recognize individuals by looking at their faces. How would we direct a computer to analyze a digital image to distinguish between any two human beings? There might be some human characteristics like eye color, nose shape, or facial hair that are more easily distinguishable, but many individuals could fit this same profile. Human beings possess many subtle physical characteristics that other human beings can innately recognize, but can't be captured adequately by a handful of broad rules. Moreover, it's not even straightforward how a machine can identify a human face out of a picture at all, given backgrounds and other foreground components, let alone how that face might be different from other faces. In order to solve perceptual problems like this, a machine would need to consider many more fine-grained, low-level details within images. Facial recognition problems and many other perceptual problems are better suited towards machine learning-based architectures like artificial neural networks, rather than traditional programming logic. These kinds of systems essentially do the opposite of what traditional computer programming does. Normally, we would provide the instructions or rules for a computer plus some data, and the computer would use those to generate output. Instead, machine learning works by providing a system with examples of outputs that we want, and some general guidelines to let the machine figure out the rules to reproduce the expected results. A facial recognition system may be trained with many examples of faces to be able to distinguish their various features.